Alright, so this is the last video on quadratics. I'm going to briefly get off track here. Wake up, pen. Okay. So one thing is I'm going to talk about completing the square, and I don't guess we're solving equations directly using completing the square right now, but we're going to have to do that anyway for the conic sections, so we might as well talk about it now, and then I can introduce the quadratic formula, which came from completing the square. So basically, suppose you had something like x squared plus 4x plus 3 equals 0. So now that we've been doing factoring, you just factor this, right? But completing the square means making it a perfect square on one side. So the first thing you do is get these pieces alone. If you had a number right here, you'd factor it out first, but we don't. So you get this alone by moving that 3 away, which is now going against what I told you before, that you always want to set something equal to 0, but completing the square is a totally separate deal. So we have this, and now if this was a perfect square trinomial, remember the deal was you had to have half of this squared at the end, because that's what happens when you square a binomial. So x squared plus 4x plus 4, this is a perfect square. But just like any other time, I can't just go around adding junk. So if I'm going to add it to this side, I need to add it to that side. So now this is x plus 2 squared, and this is 1. And now I can say x plus 2, I'm taking the square root on both sides, is plus or minus 1. So either x plus 2 is 1, or x plus 2 is minus 1, and then I subtract the 2. And if you'd factored this, you would have factored it as x plus 3, x plus 1. And that's, see, negative 3, negative 1. So either way, you get the same answer, but this is just a different method. And this method helps you with circles and ellipses and things where it's not just a function of x. Why is it just a function of x? So let's see. I'm going to do another one here. So let's say that it was x squared minus 8x plus 15. So again, the first thing, and you could just say, oh, I know if I square half of this, I get plus 16, and you could say I need to add 1. But let me see. So actually, I'd like to make it something where we don't end up with 1 different. Okay, so suppose we have this. Then we just move the 20. Unless part of you thinks, I want plus 36, so I'm just going to add 16 to both sides. That's fine. If that is automatically clear to you, that's fine. Otherwise, step 1, move that 20. And if we'd had, again, if we'd had like a 3 over here, we would have had to take 3 out everywhere. Okay? So that we have x squared minus 4x equals negative 20/3. We would just have divided it out. So x squared minus 12x equals negative 20. Half of this is negative 6. And I would need that to be squared over here. So negative 20 plus 36. So over here I built a square, which was the whole point. And over here I have 16. So x minus 6 equals plus or minus 4. It's taking the square root on both sides. So x minus 6 equals 4, or x minus 6 equals negative 4. Adding 6, we get 2 and 10, which is what we would have gotten x minus 2, x minus 10 if we factored. Okay, so this is completing the square. So what does this have to do with anything? Suppose that you had ax squared plus bx plus c equals 0. So the first thing to do is divide by the a, because you need to have just x squared plus something. So x squared plus b over ax plus c over a equals 0. So that's just dividing by a everywhere. And then we would move the negative c over a over there. Then, remember, we would take half of whatever this is, and normally this is a number like 12, and you say, oh, so 6, and then you square it. But this time we don't have a number. So we take half of b over a, which is b over 2a, b over a times 1 over 2, get a 2, squared. So the thing, plus. Because again, I can't go around adding jump, even if it is just letters. Okay, so this, what I've built over here then, is x plus b over 2a squared. It's just like before. It's this square root of this plus the square root of this squared. This equals negative c over a plus b squared over 2a squared. Okay, if you want. So x plus b over 2a squared equals negative c over, now this is 4a squared, if I square it out, 2 squared a squared. So I need a 4 and an a to get this to have a common denominator. So 4a squared, I have to multiply by 4a. So this equals b squared minus 4ac over 4a squared. That's just writing that in a different order. So then x plus b over 2a equals square root of b squared minus 4ac over 4a squared. But the square root of this is 2a, so I can just put this b squared minus 4ac and then over 2a. This was plus or minus, so this is plus or minus. So now if I just move over, subtract b over 2a from both sides, negative b over 2a plus or minus the square root of b squared minus 4ac over 2a. So negative b over 2a plus or minus the square root of b squared minus 4ac over 2a, they already have a common denominator. Oops. Okay, so let me find a different page and write this kind of better. So if ax squared plus bx plus c equals 0, then x equals negative b plus or minus the square root of b squared minus 4ac over 2a. And I've linked a couple of videos to try to help you memorize this, so I'm going to pause here and go get one of them and just stick it right in here. Hold on. I told you my internet was messed up, so I don't know if we'll ever get this. I linked it in this page. It's here. And I gave you another one here, and this is the one that I've heard students singing under their breath the most. I guess because it's the oldest one, and it's to the tune of Pop Goes the Weasel. But I kind of like this one, so if I can get it to work.
It's Wednesday morning, we're walking through the halls. We've got a goal.
Dumb ads. I'm going to pause this a minute while I try to load this video. I think that's probably loaded enough to get through at least one iteration of the formula. So.
And you're not gonna make us fall. First block, there's a math test. We've got to do our best. You've got to concentrate if you're in Haley's class. Thinking of all the quadratics we must solve. But first, let's inform you what it's gonna involve. AX squared plus BX plus C. Make sure it's set equal to 0, then it's easy. Everybody freezes, we don't know what to do. Racking my brain, but I still don't have a clue. I start to panic, but then I see to solve for X, it's negative B. Plus or minus square root. B squared minus 4AC. All over 2A. The quadratic formula is gonna help me out. And the discriminant.
Okay, I'm going to call that enough of that. So that's one way you can memorize it. The Pop Goes the Weasel thing is another way you can memorize it. And they are both here. There are other ways too, and I think Miss Hirsch gave you guys a link to some kind of rap one. But anyway, that's one way to solve them. If it can be factored, it's actually easier and less prone to errors if you go ahead and solve it. So like this one, if we went looking for things that multiply together to give 3 and add together to give -7, we can't, because it's not a rational or integer solution. So when that's the case, you have to use the quadratic formula. The quadratic formula will always work, but it is more likely, what with the square rooting and the adding and the subtracting, that you'll make an error. So if it's factorable, then you should go ahead and factor it. Okay, so 3, -7, 1. I think that was already equal to 0, so it's set equal to 0, so we can use the quadratic formula. So A is 3, B is -7, C is 1. Now if this was in a different order, this would still be the case. The guy next to x squared is A, the guy next to x is B, and the number by himself is C. And also be careful, if one of these terms is missing, then that number is 0. So if it was like 3x squared plus 1, then B is 0. Okay, so -b plus or minus the square root of b squared minus 4ac all over 2a. Sorry about that, I've got my little pad here sideways. Okay, so -7 plus or minus the square root of -7 squared minus 4 times 3 times 1 over 2 times 3. 7 plus or minus square root 49 minus 12. And 37 doesn't have a square root that we can even clean up. So it's just this. 7 plus or so the solutions are 7 plus square root 37 over 6, 7 minus square root 37 over 6. How are we supposed to put this in there? Nearest hundredth, okay. So So 7 minus 37 to the 1/2 divided by 6. So 0.15. And then alternatively plus 2.18. Okay, so 9 minus 9, 2. So negative 9 plus or minus the square root of negative 9 all squared, so positive 81, minus 4 times 9 times 2 over 2 times 9. So 9 plus or minus the square root of 81 minus 72. So 9 over 18 equals 9 plus or minus 3 over 18. So 9 plus 3 over 18, 9 minus 3 over 18 is 12 over 18, so 2/3, and 6 over 18 is 1/3. So 2/3 and 1/3. Now this one also could have been factored. But remember that the quadratic formula always works so long as you don't make a mistake. We've got 18, and that's negative, so they'd both be negative. So negative 1, negative 18, negative 2, negative 9, negative 3, negative 6. So we have 9x squared minus 6x minus 3x. That makes the minus 9x plus 2. So 3x comes out over here, and we get 3x minus 2, and then just a minus 1, 3x minus 2. Factoring out blob, we're left with 3x minus 1. So 3x minus 2 equals 0, 3x minus 1 equals 0, move the 2, move the 1, divide by 3. And I will say that sometimes when people see a leading term other than 1, they automatically use a quadratic formula because they figure this is pretty much a hassle too, and there's a possibility it won't work. But it's up to you, generally, how you want to solve things. But at any rate, we're at 2/3 and 1/3. I think I'll look at one more of these and then see if you guys can handle the rest. And if you can't, then let me know. So 3, negative 2, negative 3. Actually, I do need one to end up with something imaginary at some point. 3, negative 2, negative 3. Okay, so negative 2 plus or minus the square root of b squared minus 4 times a times c over 2a. So 2 plus or minus the square root of 4 plus 36 over 6. 2 plus or minus the square root of 40 over 6. And I don't know if you remember how to simplify these, but basically because there's an implied 2, every time you have a pair of numbers in there, they come out as one number. So 40 is 2 times 20, which is 2 times 10, which is 2 times 5. So this pair would come out. So this would be 2 plus or minus 2 times square root, and the 2 and the 5 are left in there, so 10 over 6. So there's a 2 in everything now, so we can say 2 times 1 plus or minus root 10 over 2 times 3, and these will cancel. So we have 1 plus root 10 over 3 and 1 minus root 10 over 3. So let's go here and say 1 plus root 10 over 3. So that's 1.39. And then with the minus, negative 0.72. Okay, so let me just try to make one up that maybe or two that have non-real solutions. So let's see, 2x squared plus 3x plus 7, say, equal to 0. So we get negative 3 plus or minus the square root of 3 squared minus 4 times a times c over 2a. So this is negative 3 plus or minus the square root of 9 minus 56. So negative 40, wait, 56, 47 over 4. So because of that negative, what we need to do is just drop the negative and write an I. So negative 3 plus or minus root 47 times I. That gets rid of the negative. And then this could be cleaned up in any of the normal ways. So your answers would be negative 3 plus root 47 I over 4, negative 3 minus root 47 I over 4, because of course the root 47 does not clean up. And then I hope to get one that cleans up before I'm done here. But all the I does, remember, is pull the negative out of the square root sign. Everything else is exactly the same. Those I don't think can be put in Desmos, but anyway, they can't be plotted. When you get an imaginary, if the leading coefficient was positive, it means the whole thing's above the line. If the leading coefficient was negative, the whole thing's below the line. So it says it doesn't pass the x-axis. So how about 3x squared minus 8x plus 24. So negative 8 plus or minus square root b squared minus 4 times a times c over 2a equals 8 plus or minus square root of 64 minus 288 over 6. 8 plus or minus the square root of negative 224 over 6. So 224 is 2 times 112, which is 2 times 56, which is 2 times 28, which is 2 times 14, which is 2 times 7. So I have 1, 2, 3, 4, 5 2's, so I have 2 pairs of 2's. So this is 8 plus or minus, I have 2 2's, so 4. It's not 2 plus 2, it's 2 times 2. So this is 2 squared times the square root of negative 14 over 6. So 8 plus or minus 4 root 14 I over 6. And these all have a 2 in them. Because it's top and bottom, I can cancel out 2 and 2. So 4 plus or minus 2 root 14 I over 3. And so you'd have 4 plus 2 times the root 14 times I over 3, and 4 minus 2 times root 14 times I over 3. Okay, so I'm going to call this one done now, and I'll get you guys some practice and a full assessment up at least by tomorrow night, but I hope to get some of it up tonight.